What's up, everybody? This is Aircrete Harry, and today my guest is Doug Lacy. And Doug Lacy has a really interesting building system. And like you may know, I'm very interested in a wide variety of building systems because you never know what situation you might be in where you might have to change your system. So I really appreciate all different systems like earth systems where you're using Adobe and Cobb, my own system where I'm using airforms and cement. You got Earthship system. So there's a lot of systems. And I don't think enough people know about Doug Lacy. So I'm going to let him speak about his system. But first, let's say hello. What's up, Doug?
Not a lot. How are you doing, Harry?
Pretty
Thanks.
good.
It is.
Awesome.
The building system, it's a little bit different, and I focus on the the core structural element of the building called the core monolith flex shell pavilion. So you're concentrating all of your heavy, high work, heavy labor materials, which is this high strength reactive powder composite onto just the core of the building so you can get all the benefits of its high strength ability and stuff in using this shape that is a balanced dome on columns that is kind of a fluid curvilinear shape that, under bending strains, it can distribute the loads. And it also, that basic shape, balanced dome shape, which kind of looks like a mushroom, is actually blended with a dome. It's just a kind of a base architecture for making sturdy shapes, and it creates an insulated roof. The shape also makes roof gardens, and since you're building with columns, you build in the wild terrain, so there's less disruption. You can just go right in and you start building on the side of the hill with your columns. And then the second stage of construction, you use that same high strength thin shell material to make retaining walls to terrace in around those columns. And then you do secondary terracing with that for like your access pads and things like that. So it protects that main pad from columns. And then, you just have a wall that goes up to the finished floor height. It could be a very short wall, only 3 inches high, but it establishes that level pad. And then you can fill that with rubble or cellular concrete. And that actually makes a better foundation than a grade beam foundation. And it's all, blended with the drainage, the flow of nature, and it's not so destructive on the landscape. And that happens to make a stronger foundation. So I focus a lot on the foundations and the core of the building. And then so that leaves this, kind of trippy looking dome building that looks like some kind of, Romulan retreat or something, but it's really wild looking, but it kind of blends in with nature. And then you build your entry walls between the columns. They nestle in as a separate kind of thing, and you can use sandbags or glass or foam concrete or whatever you like. I'd have to show you a picture of it to really get it.
Yeah. Well, when you mentioned columns, the first thought I had was building on a slope because when I was first looking for property in Colorado, it's easy to look at it online and not have really a clue of how much of a slope the property might have. And when I went out to actually visit properties, I saw so many of them, I just had to scratch off the list. The prices were great, but the slope was terrible. And as soon as you mentioned columns, I was thinking I did buy one property, my very first one, and it was on a slight slope. It dropped 10 feet. Every 20 feet out, it went down 10 feet. So it
Wow.
had a slope like that. So when I was designing my dome home for there, I had to design columns for my foundation. That was the only way to put in, because I'm thinking I'm building myself. So this was the process I would have to go. Now, when you mention columns, I've seen photos of your work, so I have a better understanding already of how you could basically, it would almost be like an umbrella. You can have a column going in, and then the top comes out like an umbrella,
Exactly.
So I'm like, wow, that would be perfect for sloped areas. It would just make it so much easier. And then, you can always level that area out afterwards. But that was just the first thought popped into mind when you mentioned the columns.
Yeah. And when you protect your columns with a retaining wall, that is, that's a double combo of a really high quality foundation. So it's better than a grade beam. But when you add the curvilinear element to it, that makes that retaining wall much stronger. And rather than, normally when you build a retaining wall, you have to do forms, and there are straight line forms to get that 10 inches of concrete and that rebar crisscrossing at 6 inches. This shell material will achieve the same thing as that 10-inch concrete wall, reinforced concrete wall, in about 3/4 of an inch to half an inch of shell. And you also have that fluid shape capability, which allows you to really customize what you need for a given area. And since it's a waterproof material that just gets stronger over time, you can kind of, for those retaining walls that are outside of your building, you can kind of channel the runoff water into them. So you can store the moisture and the runoff and the rain, the water underground. And so, yeah, it's just way more stable. Sometimes, if you're on a really super steep terrain, sometimes it's better to span the ground. Like, you may not be able to make one of those cupping retaining walls that will hold back all of that soil pressure, because it's just, that might be too impractical. But you can still build off of the funnel columns, or just use standard like deck and joist design using ferro cement deck elements and using the same wire block kind of form.
You mentioned curvilinear, and I know it's also along the lines of parametric designs when it comes to homes. We'll show photos in a moment. What I noticed was really cool when I was looking those phrases up. I didn't see a lot of home designs. What I saw a lot of were commercial buildings. So there are a lot of commercial buildings with these designs, and they're very fluid looking. They're absolutely beautiful. And I've seen these designs before and said, wow, if that was just shrunk down to a house, how nice would that be? And that's basically what you've done, your designs.
Also with the shell mix, the reactive powder material, this high strength self-healing cement that is very much like Roman cement, but about 6 times stronger than Roman cement and about 3 or 4 times stronger than modern concrete. We have this now, and normally the people who are making it, they're making it in laboratories and making these precast elements that are made on using really expensive parametric design software. What I found with this framing system and stuff, that's all not really necessary. It is actually turns out to be very easy. It's just a cake recipe to make the best reactive powder shell mix you can do. And you're making 6-gallon batches. So anybody can get rid of that mix before, not anybody. It's not hard to get rid of that amount of material while it's at its optimum consistency. And, in this parametric design, building with these blocks and these ribbons, it's a way of actually blending shapes. You're using reference curves that you draw with a pencil on a piece of graph paper. When you combine that with another curve going in another direction, if you were to do that graphically, it would be expensive work just to have that drawn with a computer. But you can actually build those shapes and still have really solid reference lines for critical dimensions, like your entry archways, so that you can fit a standard door from Home Depot, or, to make sure you have a structural curve, because you can follow the graph paper. But you blending these shapes, you're able to kind of free form, parametric design, which is like another way of like kind of tuning into that structural blended fluid shape kind of engineering style, doing it intuitively.
That's awesome. So people can just custom build their own home and just go with a flow. If they feel like going this way with it, they could just go that way with it, with the framing. And then once you put your skin coating on there, then we have our strength.
Yeah. And I think, I used to think that too, that we can just go out there and make like these trippy fluid melting hobbit homes. And we see a lot of really incredible art out there of parametric, organic, or fluid designs, they call them, what people are making. But I think it's really important to kind of separate your peanut butter from your chocolate, or the two pieces that would seem like they go together, and do your core form first. Because if you try to tackle the whole design, you're bringing in a lot of kind of also subconscious or intuitive kinds of things of trying to make a finished home design. And it just kind of collides with everything going on. And building the core monolith pavilion first, you're kind of creating a dialogue with the situation. You're creating a very bare boned fundamental form of your structure first. That's paying attention to drainage, and it's paying attention to the sun. It's all the things in a house that most people kind of ignore. When we think of design, we kind of look at things along this wall version that kind of follows our typical line of sight when we're not looking down or looking up. And I think that's important, because then you're more able to be artistic, to express yourself with your entry wall design and express your individuality in that context. And plus, you're building in the shade under a solid structure that the engineers really like. A lot of the obstacles moved out of the way, and you're just literally just building your walls out of whatever material on a flat, smooth floor, and you're binding it to these curved columns in your curved archway. And there's no mechanical bond. You don't put nails, you just plaster it in. It's better that it doesn't have a mechanical bond, because in an earthquake, the walls will move differently than the pavilion, and it'll help stabilize it if they're not bonded together. Kind of like how the pagoda pole that hangs free swinging in the middle of a pagoda kind of prevents it from falling down in an earthquake. They both work to kind of stabilize each other, and it just simplifies things. And then if you want to change your walls 20 years and build it out of glass or Coke bottles or whatever, you can do that. So it just makes it more of an adaptable design, and it helps you kind of see what's going on around you, and that really influences your design and what you might want to build.
Yeah, that's awesome. So you have some photos you can share with us so we can see some of the parametric designs we've been talking about?
Yeah, I recently finished where'd it go? I recently finished a project. Those are the funnel columns within a pavilion, and they actually follow a very specific geometry. It's a straight column that comes up 2 feet above your finished floor height. I mean, the finished floor height on those two columns, I think, are about 15 inches up on the column. But then it starts this curve, and the curve is relatively consistent in all directions, but it's about a 15.5 foot radius curve that starts from that 2 feet high cylinder that comes up from finished floor height. And that 15.5 foot radius goes up to about 5.5 feet. And then at 5.5 feet, which is, eyeball face level, it'll blend to the other curves that are needed in each direction. And it goes into and that approach just simply allows you to have good head and shoulder clearance around your columns when you have your finished floor height. So it's something good to pay attention to. And it helps you kind of ensure that your entry archways have enough of a height that you can just install a very basic door frame in each one. I mean, you may not want to put a door frame in a certain wall. You might have, you want that wall to be a mud fireplace. And but someday down in the future, somebody might want to put a door there. So it's good to keep it flexible in that way and just have that standard height. And in any of these rules that I talk about, they can be broken, of course, but just more like guidelines, like the pirate code or whatever. But there are some structural things that you want to follow. Like if you're doing say like a 10 to 11 foot span across your room, you can go really a small thickness and a small column height, that is like in the 12-inch to 18-inch range. And if you go beyond that, around 16 feet, you're in the 18-inch thickness for your stress skin roof.
One of the things I noticed from the image, being how you're building with columns, you don't have the amount of cement that's usually you pay for, but you don't see for foundations. Typical foundation, that entire diameter or square area would all be concrete. And if you're in like Montana, you need 48 inches underneath to avoid frost even. So using the columns, you're already saving a ton of money on concrete you don't need in your foundation. So that's pretty awesome.
Yeah. And not only that, but these hollow tubes, these are hollow tubes. I don't know if I can, there's the house I built in 2000. That was built on the anniversary of the last fully monolithic poured house. that was Thomas Edison's project in 1901. And it's filled with, cellular concrete, aircrete, all the way from the walls all the way up. And, it's on the market. It's doing really well, solar design. But that's not the system I use anymore. That was the old parabolic stress skin system, because I found that building with grade beam foundations was not as strong as building with these columns. This is the better approach, I've learned, and it gives you a lot more flexibility, and you get a much stronger, and yeah, you're reducing the amount of cement by 90% for your foundations. We had a foundation man come out and cast regular concrete for that home. Yeah, and it took more cement than the entire building did. So,
Wow.
Reinforced concrete design can be replaced with a thin shell design that uses high strength cement and a different kind of fabric reinforcing, like what I use. And then when you take that to the curvilinear design, where you're using curves to even reduce more cement by making stronger, lighter designs, yeah, you're really economizing the material quite a lot. And a lot of people criticize the building system, people who build out of Adobe rammed earth, and it says, wow, it's just cement. Cement is evil. It's, global warming. But this material continues to bind with CO2 from the atmosphere indefinitely. It continues to get stronger. It uses less cement than a mud house would, because like the foundations, what you mentioned.
Yeah, my thinking has always been, since I'm building domes, I'm also using a thin shell, so it's very little cement. And that's one of the reasons I was really turned on to domes. But this here, you're getting your dome with these columns, so it's even less cement than what I'm building with. Now, let me ask, from the bottom of the ceiling to the roof to the top, how thick of a cavity is that? Because it looks, from the images, it looks pretty thick. I'm just curious how much
Yeah,
is between the two skins.
it uses, I'm going to show you, have to show you one of these blocks. This one was doing like a 16-foot span. So we used one of the 3 block. This is what we build the trusses out of, have a little folding machine, and we use the hog green gun to attach them together. And so, I call this 18 inches, but, with the surface shells, the 3/4 inch surface shell or on each side, and plus it's a little bit more than 18 inches in reality. It's about a 20-inch one, or you can call it, I sometimes refer to it as 18-inch just because I'm referencing these 6-inch spaces, but it's really about 20 inches. And that is plenty strong for, if you were just going to do a straight barrel vault, certainly plenty strong for doing a dome shape, which is much stronger. All of that bowl flaring that you see, oh, that's the crack healing. I got some images of that, but all that bowl flaring that you see for the roof garden, that balances the forces in a dome. So as you know, like when you build a dome, it has spread forces that makes it want to flatten out, and you have to contain that somehow. But they're always present, and even any arch. And so like in the Byzantine era, they would use buttressing to kind of support those arches or domes, counterbalance that spread force. And this is using these roof garden bowls to achieve that same thing and to make a balanced dome. So this is so making a balanced dome, which is more necessary when you're not building on the ground. When you're building up on columns, it happens to make roof gardens and a garden environment, because you're leveling your pad with curvilinear retaining walls that direct the water.
That roof line looks like it's would be real good at capturing water as well. Do you have a channeling system to divert water to one side of the structure or the other?
Yeah, it comes out on the back of this staircase. All the water that overflows from each of the gardens, it has a 3/4 inch brass connection that works as a clean out and drain, and you can interface all of your plumbing features that might say heat the water or aerate the water or move the water, but you can just open it up and use it as a drain as well. That's right at the bottom of the funnel, and those don't leak. And you can actually put a cap in there that will allow you to have like 6 of the 1/4 inch tubes sealed in there, so you can have a loop that will heat the water, a loop that'll, or an air line that will aerate the water. You can control the level, you can control you can manage the water through that. But my first funnel columns, I use these heavy duty 2.5 or 2, they were 2-inch, stainless steel connections. But I think, yeah, the 3/4 inch brass is plenty. Here's some of the roof gardens up there. And that one that's filled with ice over there in the corner, it looks like it's 50 or 60 gallons, but when I opened the valve on the bottom and drained it into my water tank, because I didn't want to haul water, and I was all of a sudden making my own water to finish the job, it was more than 200 gallons. So it's really
Wow.
deceptive how much water it holds. And then it takes these frame pieces that sit on these little level shelves that will support soil. And so you put about 10 or 12 inches of soil above the water, but without it touching the water. And then you use these wick channels. So it protects that water from evaporation because it has the soil on top of it, but it'll maintain the perfect amount of moisture in your soil all the time. So you can really have high production gardens in those little bowls. It's a great water tank material. The material, after it has this late strength gain effect, that after about 90 days, most concrete, it's seeing most of its strength around 30 days. The reactive powder mix, because it's depending upon these lime and silicone reaction, the pozzolanic reaction, and lime and CO2 reaction from the atmosphere, it's characterized by this late strength gain, and it goes up in about 5 weeks after, and then the crack healing effect will kick in, and you can actually see any cracks. They start bubbling, the water comes to them, it pulls water to it, and it just fills them up solid with calcite crystals, not just lime, but when it actually produces that
Crystalline structure, yeah. So you have a lot of strength with that.
because I'm using two different kinds of metals, I think it electrically helps it, but it's very alive. It's like, it transports water, and it goes through these phases that you can visually see. It's pretty amazing. Yeah, and everything I built, it hasn't degraded, and there hasn't been any degradation of this kind of mix, and I don't expect it. Doesn't seem to be bothered by rust or ice because of that closed cell foam aeration, the Aircrete I put in that 8 to 11% foam in there, and that gives it impact resistance, and it protects it from chemical expansion. So yeah, these can be around a long time. It's not going to break down like regular mortar or regular stone.
And
It's just
how
going to.
thick would you say your structural layer is? Your cement layer, how thick do you apply that onto your lath?
Yeah, that's a good question. I do two coats, and I used to think I really had to do one coat to avoid that delamination. But since this is a low shrinkage cement, because it has such little amount of water, you get incredible bond strength between the layers, particularly if I do the rake scratch. So yeah, I start off with it being about, some of it is embedded into the lath. You put it on little globs, and some of it gets embedded into the lath. And then you put a layer that's about a 1/4 inch to a 1/2 inch above the lath, and you gauge that with your trowel as you go. And then the second layer on top of that is about another 1/2 inch. So it's about 3/4 of an inch. To take a long time to answer a very simple question.
So that would be on both sides, on the top and the bottom would be the same thickness.
Yeah. The awning part, the single shell part, that is actually a lot thicker, because I have to do those two coats from the bottom, and then I have to do two coats from the top. So it's around an inch, sometimes an inch and a quarter on that. And there you can see the crack healing effect. That's right on the ceiling, but it's bringing water to it, and it's bubbling in the lime.
Yeah, that's really interesting. I like the photo you had of the staircase. It just really lends to what you said, where it's very organic shape you can build, but you don't have to really modify your landscape to build your home. You like that staircase you built around a tree. And
Yeah.
so that's a really cool example of how once you're on the property and you've built the main structure as you was describing, from that point you can then look in what direction you want to continue building. That's really cool how you go right between the two trees like that.
Yeah, it's very easy to form, and there is a principle of design that I follow. Normally, people who do sculpture, well, I think they're going to use like single strands, like single rods. But when you use this material, you're building with ribbons, which are like two lines that are locked together like a train track. Much like these blocks, I just use one side of those and make these ribbons that are just that 6-inch square. And so it's something interesting happens when you build with ribbons instead of lines. It's like if you imagine a train track coming over a hill and all you can see is the train track, like it's glowing in the dark. And you can see a little bit of the hill and what's going on, but you have another one intersecting it and comes in and intersects that track. It reveals a great deal about what's going on. So my point is when you build with by blending these ribbons together, you're kind of exploring shape and also like revealing shape that is actually there. So you can connect two structural points with a really structural curve, and then everything else will just kind of manifest. It's a very fun, very rewarding way to build because it really is a truly a parametric fluid shapes that you're kind of whittling out of the air.
Yeah. So let me ask, how would you close the structure? If you were going to make a home, you were going to have your walls enclosed and windows, what would be the thought behind that? I can see how I would go about it, but I'm curious what's your plan and how you plan to go about that.
Well, me personally, I've always tried to encourage, other people so that I can kind of have a common dialogue or get along with people who build out of mud and different things like that. It's like, hey, I've taken care of everything that you don't do, the foundations and the roof, and all you got to do is make your mud walls. But for me, I would actually use the same material. I'd build with the blocks, and I would use the blue foam, like how I use the water tanks, because I like to make the sculptural doors and windows like the seashell window that's on my website at Flex Shell Architecture. You can put hardware into blue foam using the fiberglass mesh and that polymer modified mix. It doesn't wear out because you're bonding it from one surface to the other. It's the same stress skin principle. Things like latches and hinges, they're just going to last forever because of the way they bond to the surfaces. They don't weaken. So I like that, and I like the fact that I can sculpt doors that will seal. And I like the idea of like making windows that have shutters that you can close, and then you can open up the shutters on both sides of the wall, and it will make like a table that will connect your inside space to your outside space. And I like the idea of also using that really low voltage 12-volt plumbing. I just think it's really versatile, and it's a lot easier, and you can use water reservoirs much easier rather than trying to bring in conventional plumbing and stuff. So that's the kind of wall systems I would do, is very sculptural windows and sculptural doors that are pretty unique. And also I would insulate the walls and put some fire protection on them because, the pavilion is really fireproof. It's more resistant than standard mortar. The walls I'm concerned about. That curled edge awning that is, kind of natural to making that balanced dome effect. It'll rotate the rapidly rising air back down so it can push away a wildfire that encroaches. But still, I want to have solid walls for mine. So I'll do a combination of the blue foam and build out of these wire blocks and plaster for myself, because then I have that hollow interior. I can put the plumbing, I can put
Right.
battery.
Right. That
Yeah.
makes it much easier for plumbing and electrical running through
Yeah.
there. So you remind me of when you mentioned, what you do first is the roof and foundation. It reminds me of George Nez, who spoken about before in the past. And George Nez was somebody, I believe, back in the 60s, was commissioned to make homes for people. And I forget the number. It was a large number, like 10,000 homes. And his concept was roof first and let the locals, whatever country he's in, build the walls however they wanted. But he provided a waterproof roof that was a hyperbolic paraboloid shape. So it was very
Love.
strong, thin coating of cement. We all stand on the shoulders of the great ones that came before us. And so I was standing on Nez's shoulder when I'm using his technique of mixing my own latex cement mix. And
Oh, I think I remember him. Yeah.
yeah,
Yeah.
he,
He
he
was
came out with the latex cement mix. and he would use fiberglass mesh, thin strips that he would put between wood beams in a hyperbolic paraboloid shape, and then he'd cover it with like maybe a quarter inch or up to a half inch of his latex cement mix. And he had these solid roofs, and the locals would build whatever type of wall system they wanted. And so you remind me of that, but you're doing dome shape with these columns. So it's very different, but the same concept as you have a solid roof that's waterproof and it's not going anywhere. It's probably being dome shaped, hurricane and tornado proof, which is great. And yeah, it's a great system. I was thinking personally of a simple aircrete walls as well as
Oh,
another method for building out your walls.
yeah, I love the neat cement or the cellular concrete, which is just that the aircrete, the foam. Back when I was doing, foam concrete back in the 90s and 2000, there was another person that had this aircrete material. So they trained us not to say aircrete back then, but I think they've gone away. It was like this super light insulation that was like cigarette ash when you touched it, but it insulated your walls. I really love it for, having that flowable fill that you can just pump right into the walls.
Yeah.
I mean, if you had a free pile of pumice that you can just shovel into the form, that would be fine. It doesn't have to be cohesive around that frame. It would be just as solid if it were a concrete, because that stress skin and frame really contain it and give it the strength. But fact that you can mix and pump cement, cellular concrete with one person, and you can do like 6 or 7 yards, an hour or more, it makes it very inexpensive because of that labor saving effect. And so, yeah, I love that. I probably pump that into the walls to create that insulation and get that nice balance of thermal mass and insulation like those pumice-crete people do, if they're 3-bag mixes, that's amazing. I think we kind of have to stick in that 4 to 5 bag per yard range, get something structural, but it's worth it. It's nice stuff.
Yeah. And as far as aircrete for insulation, I'm hoping this coming week I'll be getting my results. I sent in about 4 samples to an R value engineer to be tested. The Epic Aircrete, Styro Aircrete, and another custom mix a customer of mine sent to have tested. And so the Aircrete mix I made was a 60 gallons. Basically, so I made as high of an insulative aircrete I could make before the bubbles start collapsing. Now, I've gone up to 200-gallon mix before, but I got too much collapsing of my bubbles, of my aircrete. So I have a 60-gallon mix. I'm really looking forward to getting these results, to finally knowing what my R value is for that, because that 60-gallon mix is what I use to pump into my structures for insulation. So for an example, I built what I call the double shell aircrete dome, where I built 2 shells using ferro cement, and I left a cavity, and then I filled that cavity with my aircrete. And so I really like aircrete for insulation because it's inexpensive. 1 bag of Portland cement you can expand to 60 gallons. But that's really incredible material to use, and it's fireproof.
You're just right above 3 bags per yard. So you're matching what the pumice-crete people do. So that's pretty damn good, man. I never thought that was possible. Every time I do it, I have collapses and stuff. But that's a great accomplishment.
Well, probably all has to do with my thickening agent. I have what I call the Aircreteharry thickening agent, and it is magnesium based. It's one of the ingredients in it. It's really good. It's increased the strength of my aircrete. I really could not believe the first time I did a test where I built 2 plastic columns, 8 feet tall, and I filled them with aircrete. One I filled with aircrete made using a 7th generation dish detergent for a foaming agent, and the other one I used my Drexel foaming agent mixed with my aircrete thickening additive. And I made these 2 columns, and the next day I went to them and I touched the one without my admixture in it, and my finger went right into the aircrete. And then I touched the one that had the additive in it, and I couldn't even make a dent. And this was the next day after I poured it. I was
Uh,
just completely amazed at the strength it gave. As
that
far as being able to pour tall pours, I had no problem with either one. Like there was a lot of talk in the past that you could only pour like 12 inches. Not true. I've gone up to 8 feet with both mixes. There was no problem with that.
Yeah, I can relate. My first house, that one with the seashell windows, you saw, I'd poured 8 feet. I was, and the walls got hot, and it started bleeding from around. It was like a sinking boat, and we were all panicking. It worked. I had a little bit of collapse from that, the amount of heat that came off of that, and we were using a 5 bag per yard mix, and so there was a lot of heat of hydration going on. But yeah, you can do higher. I was going to limit myself to 3 feet after that lesson, but yeah, I think you're right. I think you can go high, especially with your stabilizer.
So yeah, it's
Cool.
definitely makes a big difference. I add this to my regular cement mix when I'm doing shotcrete or whatever I'm doing with cement. I always add this in. But with aircrete, it really increases the strength of it.
Wow. Wow.
Yeah, excellent. So I figure while we talk, I can have your video playing that you have on YouTube now. Last project you built, right? The photos we were just looking at?
Yeah, that banana yellow building there. And here I'm connecting the stress skin hollow core to the single shell awning that provides its lateral reinforcing. And I'm just showing how to embed right here. This is the embedding layer. So I'm just plastering off the tip of my trowel like a beginner, and that's kind of necessary, so you're not wasting the cement by pushing too much through, but you're pushing enough through to get that really good bond.
Right.
And that's just like a super thin layer. And then as soon as I'm finished putting that super thin layer on, and I follow up. And I think I talk a little bit about making the cold joint. So this is when I got really good at it. The mix has really improved. It was a really windy day. The corner of the tarp broke off and kept slapping me as I was talking. That's what I do. You plaster little tiny sections at a time, and I like to emphasize that because whenever I work with another plasterer, they really want to do these large areas and at once, and it kind of gets away from them. And and then you're having to try to float and smooth out something that's already kind of set, and then you're trying to push on your second layer on something that so it's cracking. So I try to really emphasize this, do one little tile and move on. It's just as fast as trying to do everything at the same time.
How much do you mix at a time, and what's your working time after everything's mixed?
Yeah, I have reduced it down. I was doing half batches for the first part of this building, but then I reduced it down to quarter batches. And I tried quarter batches before, but I had some other unrelated issues that caused complications. But now the quarter batches are working perfectly. And I encourage everybody to do the quarter batches, because now you could use the least expensive mixer that you can get out there to do a top of the line reactive powder shell mix that's going to do better than you're going to get above 12,000 psi. That guy I helped in Australia, that Thias Nowie, who won that award for the Go Bug house, he was getting like 14,000 psi for his shell. And so other people are able to reproduce this using their own local materials, their own local fly ashes and things. And so, yes,
14,000 psi is massive when you consider most foundations are like maybe a 4,500 or 5,000 psi, even less sometimes for homes, could be 3,500 psi concrete mix. To be able to take that same cement and with the additives, the technique you suggest, get up to 14,000, it's incredible. And it explains why also this thin shell system works so well, because you have so much strength in the skin. It's insane.
yeah, and really, I mean, even mortar at 4,000 psi is plenty strong. People have been doing ferro cement for a long time. It's plenty strong, but the benefit you get out of making it stronger is it pulls it's a low water mix, so the particles come in closer to react, and you have that secondary pozzolanic reaction that seals the concrete and makes that reactive powder effect, which means the self-healing cracks will happen. And so that's important, and you get that extra durability with that higher strength mix, because it continues to get harder and harder over time. And that's important. I mean, normally a ferro cement water tank has like a 10-20 year lifespan, whereas a water tank made with something like this that's just not going to get weaker. Who knows? I spout out numbers that go really out there, but we don't really know. But we know that it's not going to be damaged by chemical expansion because of the aeration, because it's a kind of aircrete. And it's not going to be damaged by ice, and it's pretty strong for the impacts. And so yeah, it's probably gonna stick around.
Yeah, absolutely. That's definitely good. I mean, like you mentioned, ferro cement's been around a long time. It works. We all know it works. We see ferro cement. I've seen ferro cement tanks all over the world. I've traveled around the world and I've seen a lot of ferro cement tanks. But the big difference is you're using what most people have been looking for in the concrete world, which is a Roman type concrete, a self-healing concrete. And so you're combining the self-healing and the strength and the waterproofing you're getting from such a thin coating is really, to me, a no-brainer. And when I first came across your YouTube channel and I saw you talking about your cement mix that you were using at that time, and this was 15 years ago, I was just blown away. Thought, man, that's what I want for my home, because I was always looking for maximum strength. And at one point, I was thinking of building a dome using a magnesium-based cement, but the magnesium-based cement was so expensive. It was like 75, it's basically $1 a pound
Oh wow.
for the magnesium. And so they come in like 70-pound bags, I think. Let me see, I just 75-pound bags, and it's about $73 per bag. And so the good thing about the magnesium is, it's natural, and you have other ingredients, sand and things with this one company I'm thinking of. But you had a 8,000 psi to 10,000 psi strength with this magnesium-based cement. So I considered it, but once I calculated how much it was going to cost me to build my dome, I went from 15,000 in Portland cement to $60,000 in magnesium cement. And that's that was what turned me off to it. And I just couldn't afford as much as I would have wanted to. And I adjusted the thickness from the Portland cement at 3 to 4 inches down to 1 to 2 inches for the magnesium. 2 inches at the base, tapering up to 1 inch at the top, 1 to 2 inches. And so it was just really expensive. And I got to the point now where I decided I'll still use magnesium cement only as a very thin coating on the inside of my house, just to have it covered in magnesium on the inside. It's a much safer material. It's better energetically what it does. There's a whole thing with energies. That's something I'll get into another time. But energetically, and just the health of having that mix. Because there's so many people that contact me and say, oh, I want to build, but I don't want to use Portland cement. I say, well, I'm not the guy. There's a lot of earth people out there building with earth, adobe, cob. I'm using Portland cement because I've decided it's fine for me. I don't have an issue with it. Once it cures, it gets to a point where there's nothing to be concerned about, especially when you're coating it with a painting layer or whatever. But I really like the idea of the magnesium coating it because of the properties of it. But what you have here with this self-healing cement is what a lot of people have been looking for, who are in the cement world and looking to build. And you have it. And you're teaching and you share your techniques and your practices. And I think that's awesome.
Oh, thanks. Yeah. And I was, nearly convinced to just drop everything and switch to a magnesium shell mix, the ceramic cement styles. Consulted with this expert on that stuff who teaches in Singapore, Jonathan Hampton. That's his name. And, about had me convinced, but, it would be like materials that would be hard and expensive for people to get. And right now, the reactive powder cement seems like a no-brainer where we are that lime, because lime is produced as a wasted byproduct when you make Portland cement. And so it's a no-brainer to me to, like, if you could change Portland cement to make it be more like Roman cement to where that lime is used, then to make a better product that causes you to reduce cement by 90%. And, the high strength ceramic magnesium cement would do the same thing. But it's just not developed yet. I think I'm totally open to new shells and new materials to go on the armature. But right now, yeah, this reactive powder cement, it offers real solutions for cutting the greenhouse emissions and creating actually a market for higher quality cements rather than, these alleged green cements that they're coming out with now, where they're, throwing in, they're just making it weaker and unusable for people like us. Ground up cement, they're throwing ground up cement in it. And when we really should be going the other way, improving the quality of our materials, and so that we can use a lot less of them and cultivate these markets for making Portland cement carbon negative produced product, because we make these reactive powder cements, they're going to consume more CO2 than what's emitted. And so anything that changes that equation is and starts to put, CO2 back into the earth is a good thing. But yeah, I'm all for the ceramic cements, and I would love to. I wish I had another lifetime to dedicate to that.
Yeah. Yeah, it's some good stuff. It actually, the company who makes the magnesium cement I'm referring to is out in Las Vegas, and they're called Giga House. And
Giga house.
yeah,
Okay.
Giga House, if you're not familiar, their homes are built using custom made steel studs that they produce in house. And then they have CNC wire cutters, and they'll cut foam out, and they'll cut the shape of the studs out. And so after they place their steel studs, they slide over these foam blocks, and then they'll cover it with a mesh and then a magnesium based cement. And they have a stucco and a plaster a mix, but they're very expensive. But because I'm using it very thinly, it works for me. So that's the route I'll be going, and I'll be sharing that further along in my build process.
I tried to buy the magnesium directly from the main supplier of it, which is Martin Marietta. They used to be in aerospace, but they're like mostly, magnesium raw materials now. And the guy I talked to, they were so upset back then because there was a building system that was a magnesium base called Crete.
Yeah.
And they were the only system that had a masonry roof besides mine. And I was like, yeah, another masonry roof. And it's in it. And I was like, I want to get my hands on some of this Crete and make my own plaster or try a plaster. So I called up Martin Marietta, and they were really upset that they used this material. They said it was still water soluble. Now that's before we had these advances in the ceramic cements that are now they're, making, underwater structures out of them. They are no longer susceptible to dissolving and stuff. Like I think that the Crete may have been, according to this Martin Marietta rep that I spoke with. But yeah, that's really cool. I'd love to get my hands on some anyway. And those raw materials are cheap, so they're going to have some competition if we get it out there.
Yeah. The magnesium I'm referring to is they have a proprietary mix in their own blend so that it's not water soluble, because most people don't realize magnesium oxide is water soluble. So it's not something you would want your roof, because once it rained, it would eventually wash off. This mix, they have their own blend, and I'm interested in using their blend because it's already been tested. They did the fire testing. They got something like 2 hours. It was supposed to be a 15-minute fire test where they build two walls and they start a fire in the corner. and they went up to 2 hours with their mix. That's how great it worked with heat. It just reflected that heat. And so, anyway, it's very impressive material, but very expensive. I went along the same path you did. Once I was ready to build, and I saw some documents on the website about the Aircrete and how a gentleman was dipping burlap into it and then putting it over a form, and in 15 minutes I was like, whoa. I was like, if this is legit, I mean, this is a no-brainer. 15 minutes to build a structure. But when I
Yeah.
went searching for it, I found the company was out of business already. So I was like, oh, that sucks. But anyway,
No,
the good thing is I found you and your system, and I said, well, now there's something that I can do. It's all about, are your materials available? And we're talking about using Portland cement, which is readily available. Unlike this magnesium cement I just described, I'm going to have to pay shipping to have very heavy cement delivered to me. And it might be $1,000 just to ship it. It'll probably be more than the actual material to ship. So those are the things you have to weigh and consider when you're thinking about building a structure. Do I, spend all the money on this magnesium, or do I go with Doug Lacy's product here, get his ingredients and make something that's maybe up to 18,000 psi, waterproof, thin, money saving? And that's a beautiful thing, is the money saving, because there's so many people. I get contacted all the time by people who are looking to build. They have a very small budget and they want to build something. And so what I see with what you're doing, this pavilion style structure is awesome. I mean, because you could build a bunch of those. You could have one that'll, you put your picnic table under, and then you have another one on the side, or maybe even connect it, that will have your closed off walls. I mean, I just see a lot of possibilities with this system that you're developed. So it's really cool.
Yeah, I think it's just a basic way of building. You can make like C-shaped structures. It's just a way of showing you how to span that distance and balance your dome and build with columns. And then say if you're out of college and you don't have much money and you get a piece of land, wild, crazy land way out there, it's on the side of the mountain, and you build a pavilion. You've got shade to finish your structure. You've got a usable structure, and no matter what anybody says, whatever any bank says or whatever, you've just increased the value of your property way more than what you spent for that building. And then if situation changes, your girlfriend in New York gets pregnant or something, life happens and we've got to change directions, you have something of value. You didn't go for this finished turnkey, certificate of occupancy, mortgage debt kind of thing. You've created something solid that's an extension of the land itself, and that is ready to be improved and approved by codes. A house that is you can use, and using and bringing in new technologies that are lower cost, the 12-volt systems that use small amounts of photovoltaics, not big off-grid ways of thinking, just so you can manage water to grow food. The architecture really it implies with the roof gardens and the gardens that kind of go on around it, it supplies you food and water and a legacy durability that you can pass on for generations. So that's a game changer. That kind of starts building in a whole different way than the whole consumer driven mass media marketing kind of way of thinking, where it's just get a house. A lot of people are wanting to build small because they want to feel empowered to do their own thing and escape that debt, escape that working for the man in the town, kind of thing. And
the 25-year mortgage.
yeah, we can do that. And people can become producers. It's not like you have to be, live off of your tomatoes you grow on your roof or something like that. But if you grow food and grow water, yeah, that gives you a whole nother, hand that you're dealing with when you're dealing with other people that are, who might be trying to exploit your time. And and get you to work or go into debt or things like that. It changes things. You are now more independent and you're more supporting a local economy type mindset. You can trade your foods, or not that we have to go into a barter system or whatever. You don't have to address that. You have true sustainability. You're able to take care of things and not be in a desperate situation where you know and plus you're kind of building on a slope. You're kind of off the beaten path.
Yep.
I like in the houses where where you park is a ways. You don't drive right up on your house, because if you could drive up on your house, that means somebody else can.
Mm-hmm. That's right.
And I like to have that footpath, that's a little bit of distance from where traffic goes.
Let me ask, I didn't ask as far as the cost for the pavilion that you have there. What's the estimate to build something like that?
Well, I thought that pavilion was going to cost $9,000 to build, which is really cheap, but it ended up costing more than 12. And there were a few challenges. I've way improved the framing system to do the branching Y connection for the parametric fluid shapes, rather than doing the ring beam, which you've probably heard me rattle on about before. The ring beam didn't work. It was a bad idea. I mean, I still worked with it. It was fine, but way better to do that. So now, yeah, I would say it's like shed costs. Shed materials, $25 a foot, less expensive than stick and frame. And if you get all the tools, if you get the hog green gun, you get the compressor and the foamer and a little mixer, you invest in that small amount of tools and become trained on the system. I think a crew of 3 guys could run circles around a crew in terms of cost and labor of somebody doing stick and frame construction. I
Yeah.
really do. It's for work for sure, because you're moving. It's heavy masonry work, but it's just a 3/4 inch shell, and a lot of it is getting your arms in shape, is getting in shape, and being able to do it, or hire somebody who has those skills.
Right.
And but it's definitely doable, but we're returning back to massive construction. These are hollow costs and thin shell, but these are heavy, massive houses. It's they won't blow away in a tornado, and it's worth it to put in
Yeah.
that little effort and make a masonry house that supplies water and food and is integrated into the flow.
Yeah, absolutely. I 100% agree with these type of structures that aren't going to burn down. That's so big. That's so key for me. I've seen many homes burn down. When I lived in the city, a lot of fires, and you see a lot of people lose everything. And I always say, why are you going to continue building the same way? At some point, don't you think of another thought? Something more fireproof? And so that's why, like what I'm building, what you're building, we don't have to worry about a fire. If there's a fire, God forbid there's wildfires out, I know my home will be there when I get back, you know? And if there a fire happens inside, I know it's not going to spread past whatever room it's in. Once the materials are burnt up, the solid cement concrete structure is still going to be standing there. And you
Yeah.
just repaint and clean up and you're good to go again. But yeah, so I love this all. So let me ask, are you having any workshops? Are you teaching your method at all? What's going on as far as that?
Yeah. I do some workshops. I did a workshop at the beginning of the last structure. A couple of guys came out and they got a lot. We did a little bit of plaster on the base of the cones, and I showed them how to do the trusses and how to cut the wire. And they both bought my last 2 folders, so I have to weld together another folder. I have all the pieces cut. Yeah, I do that. I think that I want to run the crew as a 3-man crew. And then if other people will come in, and rather than trying to, to do people working at once, and more like have like a few other people who are just kind of watching or taking notes or doing documentation, because and then switching off with the laborers, because it's hard work. I mean, it's not that hard. I mean, you're moving 6 gallons of material in 2 buckets up the scaffolding. I mean, someday when we get a little pump, that'll be alleviated, and it's not a big deal. But all combined and getting everything ready, and then smearing that 80 pounds of material onto there's some physicality in it, and but it's a little bit harder than you know using nail guns and stuff, but not that hard. So yeah, so I'm thinking the workshops would I can maybe fit 10 people in on one, and I'm just doing different things, different little buildings on my land, and that giant pavilion that I made up there, which is kind of a smorgasbord of many design ideas. Uh and I'm going to do 5 structures up there. So yeah, I want to get it out there. I want to write a book that would be like a guide, and then people want to come out and help out with a structure, and who have kind of passed some tests so they know what they're getting into. Yeah, I'm all for it.
Excellent. So, would you consider going to someone else's property and to teach, or are you just staying home based like I am and would teach on your property?
Well, yeah, I mean, I have talked about that, but for somebody on that level, if I were to like travel over there would have to be like some online training that would happen first. Like the material, like I build out of those mats, which are the 20 by 8 mats of the remesh steel, the 6610 remesh. So that would have to be prepped, which is, stripping that 20-foot sheet. It's stripping it down into the 2 feet by 8 foot links, and then cutting those into the smaller pieces. And that's what I build the blocks out of, and that's what I do the side reinforcing out of. It's
Right.
all this, and then that stacks into the back of your truck, and you'll need 2,000 pounds, one pickup load of steel, and you can still fit in your lath and about 80 or 100 pieces of lath, and have that ready on the job site. And some people who are somewhat trained, I could show up because I can't really get away from my situation for more than a few days, and then get them going on the process, and get a person going, because masonry project, they're big projects. Unless you're going to do like a 10 by 10 dome, you're talking a month or two of labor of 3 people at least working, and some people rotating off who just kind of want to learn. And hanging the lath, I mean, it takes me, I could hang 2 3 pieces of lath in an hour, and that seems really slow. I mean, I could go fast if I'm doing a flat section. I can do 4 or 5, but it's not unusual for a person to take a whole hour to hang one sheet of lath, because it takes 2 to 3 clips, and each one of those clips are got 130 ties in it to tie down one piece of lath. I mean, it sounds crazy, but it's really not. It's just chink, chink, chink. You're nailing
You
it in, but you
mentioned
got,
you have the hog tying machine, right?
yeah. I think I can do a workshop in that way. And I have been talking with a few people who want to do that, who are learning the system, and who are willing to try something like that. So I can get in there and do my thing and get people going on the framing. Is the framing is important. That's the whole key to make this work, is making that fluid, parametric, stable shaping. And then I can come back and get them going on the lath, because I really do. You really don't want to try to hang a whole sheet of lath. You want to chop it down in half or thirds, so that you can get your overlaps, and
Right.
shoot a little and get the edges tight. You don't want it loose. And then bring the mixer and show them. I'm trying to build a little batching station, so you just press a button and it just throws the mix on a timer using the cheapest possible mixer you can get. And it's pretty amazing that that this really high tech reactive powder mix, that the professionals use these specialized mixers that have these double spinners on, and mixing all these gummy flowers, quartz flowers and things together, that you can use a really low cost quarter horsepower mixer and pull it off. A regular mixer will work too. It's kind of hard to clean. You have to clean the blades really good in between, but it takes 20 minutes to mix. And if you have somebody dedicated to doing that, you're keeping 1 or 2 guys going all the time,
Now
and
you're talking about like a 6 or 9 cubic foot mixer, motor mixer.
Oh, yeah, that's what I use. But now with this, by dropping it down to 6 gallons, it's possible to use one of those little quarter horsepower, little, $250 little mixers you can get on Amazon. It's tricky. You have to sequence it just right. You put in your 4.5 gallons of sand, you add most of your water, which is like 2.5 quarts, in all of your water reducer, which is 8 1/3 ounces, and you let that stir. Then you add your cement powder just all at once, and then it's all about timing. And then you can pull it off because it won't go through that tight phase that'll lock up the blades, and you can keep it going and stop the mixer, put it in 2 buckets, take it to the guy who's plastering, or take it up where you're plastering. And it's having things set up, having your little brush, having a little bucket of water. You
Power
didn't do.
washer is one of my big recommendations for cleanup.
Yeah, I love those little trays. They're kind of open trays for mortar, because if you get like a steep edge tray, it's not as easy. But those open trays, I'll put down the tar paper in there, and so you can cover it from the sun, and I have my wet canvases already prepared. You're gonna roll your wet canvases out over your shell, and then pull a tarp over it as well. So you're really sealing in that moisture right away, and you're not creating a stressful working situation. You're just making a little batch. You're getting it done. You're taking a little break. You're drinking some water, and you're not like sailing a ship in a storm. It gets crazy, and there's a lot of chaos and stress when that cement mixes. There's a lot of pressure and anxiety, and
I've
but
been there before, big time. I've been there, what you said before, with the mortar mixer locking up because I put in too much dry ingredients too quick, and I can't get it going again, and I got to dig it out, and it's like, oh my God. So the process and procedures are so important just to save you time and save you from damaging your equipment or something like that. Yeah, definitely key. And I'm still working on my home, so I'm going through the stress, I have those stresses, get my batch mixed up, and then I'm using shotcrete. So I got to dump it in my machine, make sure my hose doesn't get clogged, as I'm shotcreting. And if it does get clogged, it's a race to clear the clog before the cement in the hose sets up.
yeah,
And holy cow, there's so much stress involved in it when you're
yeah.
doing it. So these procedures are very important to
Hmm.
keeping your flow good, keeping you less stressed. And yeah, I can definitely see that.
Yeah. Are you using a little progressive cavity pump where you just dump your material in a hopper and it pumps it?
Yeah,
Uh,
it's a peristaltic pump, and
okay.
so I have a shaker deck, a screen deck, to as I dump the material in, I'll hit the button for the shaker deck, and it'll shake through. So any larger pieces that shouldn't be going through the pump will get stuck on top, and then the rest just goes through. Personally, I've been dealing with the wrong sand for my pump. I've been
Yeah.
using an all-purpose sand, which is not what you want because all-purpose sand will clog any pump. And so I didn't know this. I didn't realize the differences in sand. And so the all-purpose sand I stopped using for my pump, and now I'm purchasing sand from the concrete place, and I just go there and I'll get concrete sand that's washed, and you see there's a lot of different size rocks and sand in there. So that's more of a lubricant having those different size rocks for it to flow through my pump better. And
Yeah.
the biggest rocks I could use are 3/8 minus would be the largest because that's the size of my screen deck and it won't let anything larger than that pass through. I usually try to get through all my cement mix. So in between batches, I'll clean my pump, clean the hose. I put the sponge through because the hose is black and I got a lot of sun here in Colorado. It was like 90 degrees and it will cure your cement in the hose if you leave it even for like 10 minutes. So as soon as I'm done, I wash. So these are the stresses Doug is talking about. These are some of the stresses involved because, the hoses are like $300 and you don't want to mess anything up because I don't have extra money to be buying hoses. And
Yeah.
I do have one hose that I messed up last year, and I just put it to the side. Eventually I'll get around to trying to break the cement and cleaning it, but it's too much to deal with right now. So
Yeah, yeah.
definitely.
Yeah, I clogged up a hose on a big peristaltic pump once because they brought me the wrong sand. Normally, require the mortar sand, but it's a certain gradation, and when it's river sand like that, it's naturally sorted out into these
Yeah.
different sizes. It happens naturally when sand moves down a river.
Mhm.
Yeah, I would really recommend use the mortar sand and put in a little bit of water reducer to give it that fluidity and maybe a little bit of foam, just sacrificial foam. It's going to collapse, but it'll move it down your hose,
Yeah, that's a
make
good
life.
idea. I'm gonna do that, especially since I have the phone.
Yeah,
Well, Doug, it's been, great talking to you. You have an email or any way people can contact you if they are looking to have your assistance and maybe designing or helping or to find out about future workshops?
yeah, I do love to consult and I do help a lot of people all over, with their projects and if I get the right project, heck yeah, I'll come out and help because it's my passion and if you're going to do a parametric design in the wild terrain, I'm going to be really interested. But yeah, my email is Doug Lacy, and it's spelled Lacy, no E, 77 at hotmail.com. And my website is Flex Shell Architecture. I have I'm working on the book and the publication just to kind of sort out the information as a foundation in a really basic written form, and then we'll move up to more graphic and video type stuff later.
Awesome. Well, Doug, it's been a pleasure speaking with you.
Talking to
Thank
you.
you very much. To my audience, thank you all. Peace out. We love you all, and we'll catch you later.
Take care.
Building system.